Hello, this is Ashna Patel, and this is my Physics 2211 Lab 3 Black Hole Report. So before starting, it was important to take note of a couple of factors. The first being Newton's second law, which states that in order for velocity to change, there must be a net force acting on it. There are no forces acting on an object with a constant velocity, and that Newton's second law is, as listed here, velocity final is equal to v initial plus f net divided by m times delta t. In addition to this, the momentum principle, which is listed as F net equals dp over dt. This formula can be split up into two components to then find F net and F net parallel and F net perpendicular. In this experiment, it was split into two parts. The first being to find the black hole's mass. We started with analyzing a star's motion to find the net force on the star using our personal Gotek email in the starter code provided. We then generated a unique trajectory through inputting values into the starter code and then finding the black hole's mass using the previously found information. Then in part 2, we were to calculate the initial velocity needed to fly around the black hole without a collision. So here is the GlowScript code for part 1. I added in my Gotek email as listed here, and added in the mass of the star and the amount of seconds in 1 day for delta t. I then computed the components to find the initial and final velocities and initial and final momentum vectors, as well as the velocity and change in momentum. I basically added in the formulas to calculate these values. And at the bottom here, I used the momentum formula to calculate the parallel component and then used that to calculate the perpendicular component. Here I calculated the mass of the black hole. I wrote the equation for the black hole listed here and updated the formulas to depict the forces acting on the star. So here is the final trajectory. The mass of the black hole was equal to 1.54 times 10 to the 34th kilograms, and the final F net was 9.36 newtons, and F net parallel is equal to 4.48 newtons, and F net perpendicular as listed here. So part 2 was don't crash. In part 2, I inserted the mass found in part 1 and kept the max time the same. I put in this line to calculate the planet's speed and tested the initial speed to find a point where there was no collision. I then found the F net force on the planet using the gravitational force equation as listed, and found F net on the planet and on the ship. I then calculated the final velocity and final position of both the planet and the ship by putting in these equations. And finally, this was successful because there was no collision between the two objects. So now, what does this mean? Basically, the parallel and perpendicular components of the rate of change of momentum can be calculated with the momentum principle. We find the parallel and perpendicular components of momentum are the same as the parallel and perpendicular components of the net force. However, the overall net force cannot be found without the mass of the black hole. The rate of change of momentum can be calculated because we have the velocity and mass of the star. And finally, what if? We did decide to enter into an orbit around the black hole? I think that the spaceship would need a constant velocity with a trajectory at an angle. This would only be possible if there was an extra force that matched the force of gravity, negating F net to 0. Thank you.